Welcome to this session on your favorite Resultant AJ YouTube channel. I'm Vikas Sir. Welcome you all to this special class on IC Engine for RRB JE 2024 CBT2. And if anybody is preparing for, anyone is also preparing for SSC JE CBT2, which of course you will be, most of you must have been waiting for SSC JE CBT1 results. So if you qualify CBT1, you have to give CBT2 of SSC JE, and also same for RRB JE. So for that, this IC Engine subject is important, and I am going to take some questions on IC Engine subject in today's session. Please tell me everyone if my audio and video is fine, clear or not. Please write in the comment box. And good evening everyone, welcome to this session. Yeah. So those who have not subscribed our YouTube channel, then I request all of you, please do subscribe our YouTube channel and press the bell icon also. Also, do not forget to like and share the session, my friends. It's important to like and share the session, especially to share the session. And those who have joined the session, please do not forget to like the session also. Good evening everyone, good evening. Let me know everyone by writing in the comment box whether my audio and video is fine or not. Yes, please everyone, I want all those who have attended the session, those who have joined the session, I want you to write in the comment box if my audio and video is fine, and we are going to practice the questions on IC Engine subject. Those who have joined me for the session, please do not forget to like and share the session also. My dear students, if you have joined me for the first time and you are meeting me for the first time, let me just give you a short description about myself. I'm Vikas Sir and a faculty of mechanical engineering having over 7-year teaching experience. I have done my MTech in thermal engineering from Thapa University and mentored more than lakhs of students for these examinations. These are just subjects which I generally teach, and I've been teaching these subjects from the last couple of years. You can see my total teaching experience also. You can also mail me if you are having any query. You can mail me here, vikas@resultant.in, and this is my Telegram, Mechanical by Vikas, where you can, if you are having any questions, you can just ask me here. Okay. Hi Pushpendra, good evening. Welcome to a session. These are some. I think this is not required. RBJ 2024, we are going to provide you the courses for RBJ, and in the technical part, these 4 faculties will be taking the technical subjects. Okay, you can see me, and apart from me, you can see Dheeraj Sardana Sir, Chandrasekhar Sir, and Suraj Gopi Sir. They are having years of experience in teaching for different examinations. And Pushpendra, Janatul, Siddiqui, good evening, welcome to the session. And these are the 3 types of courses currently that we have for RRB JE, CBT1, CBT2, and combined CBT1 and CBT2, and also their MRP and offer prices. Okay. So these are the technical batches and their information. You can see RRB JE CBT2 technical batch. These things will be provided, and these will be the faculties, and the price is also given. Okay. Also, we have a mission batch which is for combined CBT1 and CBT2 for RRB JE. If you want to join this batch, you can just call on this number. This is a number where you can give a call. Okay. First question on the screen. Please answer this question. Each octane number at higher level of octane scale will produce dash anti-knock effect compared to same unit at lower end of scale. Now, first of all, we need to understand what is the meaning of octane scale. See, octane scale or octane number tells us about, octane numbers tells us about the degree of anti-knock index, degree of anti-knocking of petrol fuel. How much tendency our petrol fuel is having that it will not produce knocking, or it will resist the knocking. Anti-knocking means resist the knocking. So if any fuel, each octane number at higher level of octane, if octane number is higher, then what will happen? It will produce more anti-knock effect compared to same unit at lower scale. So one is having higher level of octane, one is having lower level of octane. The one is which is having more octane number will have higher anti-knock effect. It will produce more anti-knock or higher anti-knocking effect than the one which is having lower octane number. For example, there is fuel A. This fuel A which is having octane number of 90, and we have a fuel B which is having octane number of 82. Now it's very obvious. Hello Prisma MS, good evening, welcome to the session. It's very obvious if I ask you which type of fuel will have more anti-knock quality. Which will be having more anti-knock quality? Then definitely this will be fuel A. It will be having more anti-knock effect because it is having more octane number, better anti-knock quality or more anti-knock quality than this fuel B. Clear? Next, choose the correct statement from the following. Diesel cycle is more efficient than Otto cycle for a given compression ratio. Given compression ratio means for same compression ratio. If you compare the diesel cycle and the Otto cycle and we keep compression ratio same, then which cycle will be more efficient? Diesel? Well, this is wrong statement because we know that. Yes, Janatul Siddiqui ji, I will definitely be taking the questions on fluid mechanics in this week, I think on Thursday. Okay, so we'll definitely just after 2 days I will take questions on fluid mechanics also. Otto cycle is more efficient than diesel for a given compression ratio. This statement is correct. We have discussed this so many times that if we have to compare the different cycle, that is Otto and let's say diesel, okay, if you compare these two cycles, then most of the cases efficiency of diesel cycle is greater than Otto cycle, okay, except same compression ratio. Except same compression ratio, if this is not the factor, then always you will find that diesel is more efficient than Otto. But for same compression ratio, if we compare these two cycles based on same compression ratio, if the compression ratio is kept same, then Otto will become more efficient than diesel cycle. But except same compression ratio, this will be the answer. Diesel will be more efficient. In an engine working on an ideal Otto cycle, the temperature at the beginning and at the end of the compression are given as 300 Kelvin and 600 Kelvin respectively. What will be the air standard efficiency of the engine? Consider gamma is 1.4. Yeah, the reason is correct. If you compare same compression ratio and same heat input, then the cycle which is having least heat rejection will be having more efficiency. If you compare same compression ratio and same heat rejection, then the cycle having more heat input will have more efficiency. Okay. This is a numerical question where you have to find the air standard efficiency. Air standard efficiency of the Otto cycle is equal to 1 minus 1 by compression ratio की power gamma minus 1. And how you get this relation? We get this relation by using this equation that T2 by T1 is equal to V1 by V2 gamma minus 1, where V1 by V2 is equal to compression ratio. So we can say, in a way we can say that T1 by T2 will be equal to what? It will be equal to 1 by compression ratio power gamma minus 1. So we can also write it as 1 minus T1 by T2. Just put this value here, you will get 1 minus 300 by 600 and the answer will come out to be 50%. Okay. So the right answer is option A, 50%. Hello Kuldeep. Good evening everyone. And those who have joined me for the session, that is those who are present in the session, please do two things. One is please do not forget to like the session. And the second thing is, if you think that this session is should reach to more students like you, then please do not forget to share the session also. You can just give some few seconds to share the session also. Calculate the indicate power of a single cylinder reciprocating. Oh, this is a question from reciprocating compressor. Forget about this. Okay, I think this is a question from power plant. No problem. We have I've taken this question by saying the indicate power, but indicate power can be easily found, right? You can easily find the indicate power. Indicate power is equal to what? It is the work into the speed. Speed is given. Speed is equal to what? N. But this is in RPM, revolution per minute. Divided by 60, you will get in revolution per second. If you divide it by 1000, you will get in kilowatt. Just put the values, you will get the answer. 500 into speed is 1200 divided by 60 into 1000. This two zeros will get cancelled out. 1 0 will get cancelled out from here, and this will get cancelled out from here. It is 12 5 just 60 by 6. This will be 10 kilowatt. So the answer will be 10 kilowatt. Okay, clear? Next question. Don't worry, we'll also take mixed question. In the upcoming classes, we'll take mixed question also. Okay. A truck having a 4-cylinder engine has a total displacement of 1000 cc. If the compression ratio of the cycle is 8, then the clearance volume per cylinder will be. Please read the question very carefully. Hello Pavitra Sahu, good evening. Ram Jeevan, good evening. Welcome to the session. And if anyone is left I have not seen your comments, then good evening to everyone, those who are present in the session. A truck having a 4-cylinder engine, that is total cylinder is how much? Total cylinder is equal to 4, and total displacement. What is the meaning of total displacement? Yes, what is the meaning of total displacement? Total displacement means total sept volume. We are talking about total sept volume. We are talking about total stroke volume. Total sept volume, total stroke volume is given to you, which is equal to 1000 cc, and this is a sept volume for all the 4-cylinder together. Okay. If the compression ratio is 8, the clearance volume per cylinder. We know that compression ratio is equal to 1 plus sept volume divided by clearance volume. I hope you know this relation, right? So compression ratio is given, sept volume you can get from here, and then you can get your clearance volume. But you need to get the sept volume per cylinder. Sept volume per cylinder will be equal to, for 4 cylinders, this is the total sept volume. Per cylinder will be 1000 by 4, which will come out to be 250 cc. So just put the value, it will be 8 is equal to 1 plus 250 divided by clearance volume. Just solve this equation and you will get the answer. Please try to solve this question, everyone. Yes, everyone. For more accuracy of the, for more better accuracy, you can use the calculator, because options are quite close. Answer will be 35.7 cc. Okay. Why I'm saying to use calculator? Because if you are preparing for SSC JE and RRB JE together, CBD2, then calculator is allowed. Use calculator. You can use calculator. Okay, I will not be stopping you to use calculator, because for these 2 exams you can use the calculator, but mistake should not be there. For an air standard Otto cycle, the efficiency dash with increase in the specific heat ratio, that is Cp by Cv. Cp by Cv is equal to gamma, which is also called as adiabatic index. It is basically given that in the case of Otto cycle, if for air standard Otto cycle, efficiency, what will be the effect of efficiency with the increase in specific heat ratio, that is gamma, adiabatic index. So we know that efficiency of the Otto cycle definitely depends on two factors. One factor is compression ratio for sure. If you increase compression ratio, efficiency of the Otto cycle is going to increase. But what about the second factor? Second factor is gamma. Gamma generally is kept same, but you must remember this curve. Do you remember this curve? I know that from a very long time you have not studied from me, and maybe you have not revised the concepts. That is why most of you are saying, sir, we have not done the revision from a long time. So you must remember this curve. Efficiency of the Otto cycle increases with compression ratio, but after some compression ratio, it becomes almost constant, right? It will not show a sharp increase. It will show a sharp increase up to some compression ratio, but after that, it will not have a sharp increase. It will have a steady increase. But for different gases, gamma is equal to 1.33, gamma is equal to 1.4, gamma is equal to 1.67. If you compare this efficiency of the Otto cycle with respect to gamma, the gas which is having more gamma means adiabatic index, like monoatomic gases, then monoatomic gases will have more efficiency for Otto cycle as compared to polyatomic gases, right? Based on that, your efficiency is definitely going to increase. Is it clear to everyone? I hope you remember. It has not been a long time. Monatomic gases, you will find more efficiency, and for polyatomic gases, you will find the least efficiency for Otto cycle, and diatomic will definitely lie between the monatomic and polyatomic. Next question. The maximum and minimum temperature of the ideal Otto cycle is 900 and 100 Kelvin. What is the compression ratio of the cycle for maximum work output if the specific heat ratio is 2? If specific heat ratio is 2, specific heat ratio means Cp by Cv, that is gamma is equal to 2, and this is given the question, maximum and minimum temperature of the Otto cycle. If you draw the Otto cycle, whether you are drawing a PV diagram, still you can locate these two temperatures. This is point number 1, this is 2, this is 3, this is 4. It is very easy to locate that. If this is a curve of pressure and volume, then you know that minimum temperature will lie at this point. At this point you will find minimum pressure and also minimum temperature 100 Kelvin. Also the maximum temperature will be at point 3, which is 900 Kelvin. If these two things are given to you, how you can find the compression ratio? Now, this is a question which is of important question, because you will find this question in not just SSC JE but important for RRB JE also. First of all, you need to understand what is compression ratio. Now compression ratio is T2 by T1 is equal to V1 by V2 gamma minus 1. This is equation for adiabatic process. This is compression ratio. From here you can say compression ratio is equal to T2 by T1 over 1 by gamma minus 1. But for maximum work output in the Otto cycle, this is a condition. For maximum work output, in the Otto cycle, I hope you remember this condition. Then T2 is equal to T4 becomes geometric mean of T1 and T3, where T1 is the minimum temperature and T3 is the maximum temperature of the Otto cycle. If you do the square root, you will get T2 will be equal to 300 Kelvin. This is equal to 300 Kelvin. Just put the value 300 divided by 100, 1 by 2 minus 1. Of course, you will get the answer as option C, 3. Clear? Is it clear to all of you? Understood? Any doubt in this question? If you are having any doubt, you can just ask me. Okay? I have taught you all these things. It's just that I hope you remember these things. In a 4-stroke petrol engine, intake valve closes before top dead center, intake valve closes after bottom dead center. Regarding the valve timing diagram, if you remember, I have taught you this. See why I am saying if you remember, I have taught, because I know most of your most of these of you must have seen my classes earlier where I used to teach. I have taught you these concepts. Regarding wall timing diagram, I have told you one thing, that most of the, if you see actual wall timing diagram, then any type of wall, whether it is inlet wall or exhaust wall, they try to open, in actual condition they try to open before their dead center. They have to be open before their dead center, and the wall tends to be closed. Wall should closes after their dead center. They should close after their dead center. This is a condition, my friends. Okay. Direct. You can solve the question. This question from direct equation also. There is a direct equation also. If you want me to write the direct equation, this will be the direct equation. This will be T3 by T1 1 by 2 gamma minus 1. This is a direct equation. If you know the maximum and minimum temperature, this is 1 by 2, that is square root of. Okay, this is basically compression ratio in this condition will be a square root of T3 by T1 gamma minus 1 by gamma minus 1. So it doesn't matter, it will be same thing. Okay, either you can find from this equation or you can find from this equation. You will get the same result. Okay. So what type of wall we are talking about, my friends? We are talking about inlet wall and exhaust wall. So that means if I have written this concept that the walls need to be closed after their dead center and need to be open, we are talking about the two types of wall, inlet wall and exhaust wall. They need to be open before dead center. Now, in case of inlet wall will open before which dead center? It will open before top dead center. Exhaust wall will open before bottom dead center. In this case, they will close after their dead center. So after, inlet wall will close after bottom dead center, and this will close after top dead center. Remember this concept of after and before, and remember these dead center. This is important. Clear? So as per this question, intake valve will close after bottom dead center. Clear to everyone? Is it clear? The reason I have explained this thing because most of you basically forget this thing. Even after studying for many times, you will just forget this. So remember this basic concept, whether it is inlet wall or exhaust wall, they will be opening before their dead center, closing after the dead center. Just remember their dead center. Okay. Which of the following is not a type of cylinder arrangement in the IC engine? See, in case of IC engine, the cylinder can be arranged in many ways. Different types of engines based on the arrangement of the cylinders. X engine, V engine, radial engine, zigzag engine. So you must have seen X types of engine, V types of engine, V engine, X types of engine, and radial engine. Okay, but this design of zigzag engine is not present as per the arrangement of the cylinders. Okay, the mean effective pressure of an IC engine is the ratio of mean effective pressure is basically the hypothetical pressure. Mean effective pressure you can obtain with the help of indicator diagram. With the help of indicator diagram, you can obtain, you can get the mean effective pressure. And this indicator diagram is nothing but it is a diagram of where we plot pressure and volume. This type of diagram is, and if you take a line which is mean effective pressure line, below this line you get the area below this line will give you indicate power. So mean effective pressure is nothing but net work divided by sept volume. This is one formula. Okay, work performed in a complete engine cycle to the engine displacement. So this is a formula for mean effective pressure, one formula. There is one more formula for mean effective pressure, which is mean effective pressure is equal to area of the indicator diagram, area of net area of indicator diagram divided by the length of indicator diagram, length of indicator diagram. This is the area, this is area, my friends, this is the length, okay, and into a spring constant. Spring constant, this will be given the question. So there are two ways by which you can find the mean effective pressure. Either you can use this formula, net work by sept volume, or you can use this formula. Okay, Williams line method, Morse test and motoring test can all be used to find which of the following for an IC engine. These are the three types of testing. Engine testing, when we say testing of engine, testing of engine. So what we try to test from the engine, we try to test what is the indicate power, we try to test what is the friction power, right? We generally used to obtain these data. What is the value of indicate power, what is the value of friction power, okay? But if we have to find, if we see all these three tests, motoring test, Morse and Williams, together they can find what? They all are used to find one single thing, that is frictional power. Because see, Morse test can be used to find indicate power also. Okay, you can get the indicate power also of multi-cylinder engine. And along with indicate power, you can also find the friction power. But motoring test is only used for friction power only. FP means friction power. Williams line method is only for friction power. But together we can say that all the three tests have one thing common, that they will give you the value of friction power. Now it's other thing that Williams line method is only used for CI engine. CI engine only. This is only used for multi-cylinder engine, Morse test. And motoring test is used for single cylinder petrol and diesel engine. Okay, but they all will find the friction power for sure. For a constant compression ratio, the thermal efficiency of an air-standard diesel cycle will equal to that of an Otto cycle when the cutoff ratio becomes. If we have to compare for a constant compression ratio, if we take compression ratio same, then under what condition the diesel cycle efficiency will become equal to Otto cycle efficiency? Now here we are talking about cutoff ratio. So if you see the efficiency of the diesel cycle, efficiency of diesel cycle is equal to 1 minus 1 by gamma of compression ratio power gamma minus 1. And if I denote cutoff ratio by RC, cutoff ratio की power gamma minus 1 over cutoff ratio minus 1. Right? This is the efficiency of diesel cycle, this is the efficiency of Otto cycle. Now when this efficiency will become equal? If we have same compression ratio, then at what value of cutoff ratio these two efficiency will become equal? See, cutoff ratio will become equal to 1. When cutoff ratio becomes equal to 1, which is equal to V3 by V2 equals to 1. When cutoff ratio, this is cutoff ratio. When cutoff ratio becomes equal to 1, or when cutoff is equal to V3 minus V2, it becomes equal to 0. Then the efficiency becomes equal to, diesel cycle efficiency will become equal to Otto cycle efficiency. Okay. The function of dash is to heat up the engine fast and then keep the temperature of the engine at constant temperature. So we talk about the concept of engine cooling. There is a question from engine cooling concept. So when we say engine cooling, there are two ways by which you can do engine cooling. We can use air cooling in the engine, or we can use water cooling in the engine. Basically, when we say air cooling, then it is used for small engines like motorcycle, scooters. In some motorcycle we use water cooling also. Water cooling, basically we have different types of water cooling. We have thermostat, thermosiphon cooling. Thermosiphon cooling, we have pump type of cooling, pump cooling, where we use a small pump, and then we have a pressurized cooling. In case of pressurized cooling, we use so many gadgets, like we use thermostat. Thermostat is basically used in pressurized type of cooling, where we not just we use pump, we also use a thermostat, and thermostat is set at some temperature like maybe 90 to 95 degrees Celsius, where as soon as the water which is going to absorb the heat from the engine to cool the engine, as soon as the temperature water reaches this temperature 95 or 1995, then this thermostat will immediately send this water to the radiator, so that the radiator will cool that water and send the water again back to the engine. Okay, so this is the function of thermostat. The main function of the strainer in the carburetor. The carburetor, we all know, it is a device used particularly only in the petrol engine, and this carburetor is basically used to supply homogeneous air and fuel mixture to petrol engine. But in the case of carburetor, we use something called strainer. Strainer is basically, you are thinking right, we are talking about a device which is used to separate the dust particles. It is used to prevent the possible blockage of the nozzle which is injecting the fuel. It will prevent the dust particles to enter the float chamber which is containing the petrol. So basically strainer is like we know, we use a strainer for straining the tea, right? You remember tea, you all drink tea. So when you drink tea, and when we have to pour the tea in the cup, right? So we don't actually put the tea inside the cup. We use a strainer for that purpose, and this strainer is basically consists of some holes like this, like a sieve, right? You must have seen a strainer. So we will use this strainer and then we'll pour the tea inside the cup. In the similar manner, we use a strainer for this also. The strainer is basically used to strain. Strain means to remove the dust particles and only prevent the, that is air filter. See, air filter, Subhadeep. What is the meaning of filter? What is the meaning of filter? Filter is basically used to filter anything. When we say air filter is also used to filter the dust particles. When we say strainer is used to filter the particles which are present inside the, they may not be the particles of dust, they may be the dust particles, they may be some metal particles. All these kinds of particles are filtered so that the petrol which reaches the float chamber of the carburetor, that should be clean petrol. That should not be, because when you go to a petrol pump to fill the petrol inside your vehicle, then that petrol may contain some particles, some dust particles, right? So that filter used for filtering the petrol is called strainer. Okay, that is a kind of strainer. And when we say this air filter you're talking about, that is used to filter the dust particles present in the air. Okay, the purpose is same, to filter the dust particles. But filtering is done for two different things. One is used for filtering the air, other is used for filtering the petrol. So the one which is used for filtering the petrol is strainer. The one that you're talking about, air filter, that is used to filter the air dust particles from the air, which we also use in the in our AC. It is also used in the air filter of our vehicle also. Okay. For a 4-stroke diesel engine, the compression ratio is 21:1. The cutoff ratio is 2:1. What is the expansion ratio? So we know compression ratio is given. Compression, I hope you remember we have discussed about this formula, that cutoff ratio is equal to compression ratio to the expansion ratio. If you remember the formula, it's very simple. It becomes very simple. Just use this formula and you will get the answer. Remember this formula. But if you forget the formula, then this will become difficult for you to solve this question. Cutoff ratio is equal to 2. Compression ratio is 21. Expansion ratio you can get from here. Just put the value, you will get expansion ratio 21 by 2. That will be 10.5:1. Clear? Next question. All the diesel cycle except slow speed engines use which type of fuse? Diesel cycle except slow speed. See, you must remember that we discussed about different type of cycle. We know diesel cycle, we know dual cycle. How many of you know that dual cycle is also called semi-diesel cycle? Do you know why it is called semi-diesel cycle? The reason is, this dual cycle called as semi-diesel cycle is used for diesel engine. It is also used for diesel engine. It is also used for diesel engine. But the reason why we introduced dual cycle in the first place, diesel cycle has a compression ratio of 16 to 20 or 22. Having the compression ratio of 16 to 20 makes the diesel engine working on diesel cycle heavy, right? And that obviously it is if it is having more compression ratio, then we cannot operate this engine at high speed. That means it will be operating at slow speed. So the diesel engine which works on diesel cycle will operate at slow speed. But the diesel engine which works on dual cycle, since dual cycle have a compression ratio of 10 to 12, so since the compression ratio is 10 to 12, then engine is compact. It is not that heavy. Engine is compact, and since the engine is compact, it will reduce the weight of the engine. It will make the engine less bulky, and that is why the speed is high. We can also use this dual cycle if we are using for diesel engine, but that can be used at high speed. But if we use same diesel engine based on diesel cycle, it will run at slow speed. So all the diesel cycle except slow speed engine uses which cycle? They will use mixed dual cycle. Okay. If it is not slow speed, it definitely will be high speed. So if it will be high speed, it will be dual cycle. Clear? In an Otto cycle, air is compressed from 3 liter to 2.4 liter from a starting pressure of 1.5 kg per centimeter square. The net output per cycle is 400 kilojoule. What is the mean effective pressure of the cycle? So I have told you the formula for mean effective pressure. Mean effective pressure is equal to net work divided by sept volume, right? Now net work in this question is given as 400 kilojoule. This is 400 kilojoule. So if we know sept volume, we can get the answer very easily. But how you will get the sept volume? In this particular question, it is given the diesel engine, the compression is basically done from 2.4 liter, 3 liter to 2.4 liter. That is, before compression, the volume before compression was 3 liters. The volume after compression is 2.4 liter. Okay? Clear? And now, how many of you know that V1 is also called as total volume? And total volume is sum of sept volume plus clearance volume. Please focus here. V2 is also called as volume after compression, or also called as clearance volume. So if V1 is the total volume consisting of sept plus clearance and V2 is the clearance volume, then if we subtract V1 from V2 from V1, you will get sept volume. Clear? So you will get this as 400 divided by V1 minus V2. That is 400 divided by 3 minus 2.4. Since it is in liter, in meter cube, this will be 10 power minus 3 meter cube. If you solve this, you will get 667 megapascal. Megapascal in the unit will become megapascal. Okay. Which of the following statement is incorrect for work output of an ideal Otto cycle? Ideal Otto cycle work output depends on which factors? I will just take 15 more minutes. Those who think that the session will get over soon, if you want to go from the session, then it's a power hour. It will just will be 15 minutes more, and in 15 minutes we'll discuss, I think, 10 to 12 questions, okay, which will be important for the exams. Otto cycle net work is equal to P1 into V1 into pressure ratio minus 1 into compression ratio power gamma minus 1 minus 1 over gamma minus 1 into compression ratio minus 1. This is a formula for the net work of an ideal Otto cycle. If you see this formula, then net work of the Otto cycle depends on two things. Actually, three things: gamma, compression ratio, and pressure ratio. But how it is going to vary with this? The net work will be directly proportional to pressure ratio. The net work will be directly proportional to compression ratio and also directly proportional to gamma. On these three factors, it's going to depend. I paid a lot amount. Hi Mrinal Kanti. See, about the previous platform that you are talking about, we were just faculty over those platforms, and so I'm not in a position to discuss about what has been done, not just to students but also to the faculties in that platform. Even as a faculty, I was not paid 3 months salary. And if you talk about your course, you have taken subscription, you have paid let's say 10-15,000. As a faculty, I was not paid more than lakhs, 3 to 4 lakhs amount. So this is a platform which is being started from the faculties point. Faculties of the BYJU'S have basically started this platform. So if you want to get benefit from or discount because you were a paid student in the previous organization, so I'm not sure whether I'm in a position to give you that discount. Okay, I'm not in a position because I'm just a faculty here also. Okay, I cannot help you in that. Okay. So the right answer for this question is which of the following is incorrect? They are not asking about the correct, they are asking about incorrect. Work output of an Otto cycle decreases with increase in adiabatic index. This is incorrect. Decreases with the increase in compression ratio. This is incorrect. This is correct. But a question cannot have two answers. Okay. It decreases with an increase in adiabatic index and decreases with the increase in compression ratio. This is basically combination of, this is nothing but A and B. A and B both are written here. So you want both A and B to be the answer for this question, but you can find this answer in option D. Okay. Use some discount. I haven't. See, I understand your point, Mrinal, and this must be the case with all the students who were paid course students. But I'm telling you, I'm not in a position to help you in this. Okay, if you want, you can just contact our resultant faculty. There are some numbers provided on this. If you see the description of this session, you will find few contacts written in the end of this description. You can find few contacts written here like support@resultant.in. You can find some support number, that is 799 131 0416. So maybe they can help you, but if I tell you again, as a faculty, I don't think that we are responsible for any student that if that organization was closed and you were not able to attend the classes. As a faculty, we have also been faced a lot of things. We have not been paid our salary, and so if you as a student have been think that आपके साथ गलत हुआ है, then as a faculty we have also faced a lot of things. Okay, so if we can help you, you can just call on this number. Maybe we can help you from here. Govind Haldar, good evening, welcome to the session. Engine pistons are usually made of aluminum alloy because why engine pistons are made of aluminum alloy? Because it is lighter, it is wearing will be less, it will absorb shocks, or it is stronger. It is very obvious that pistons are made of aluminum. Aluminum is recognized as a material which is lighter material. So the reason why we use piston made of aluminum, because it is lighter. Okay. Next is, in a diesel cycle, heat is rejected at what conditions? They are asking the condition at which heat is rejected in the diesel cycle. So if you compare all the three cycles, whether you are talking about the Otto cycle, whether you are talking about the diesel or dual, in all the three cycles, the rejection of the heat is done at constant volume. Okay, whether you are talking about the Otto, diesel or the dual cycle. Okay, I am drawing all the three cycles for you. So the heat rejection in all the three cycles is done at what condition? The heat rejection is done at constant volume. Heat rejection is done at constant volume. Otto, diesel and dual. The difference is basically, the difference only comes in the heat supply section. Heat supply in diesel cycle is at constant pressure. In Otto cycle is at constant volume. In dual, heat is supplied at both constant volume and constant pressure. Clear? Remember this thing. Next, the volumetric efficiency of the petrol engine is comparatively. If you compare the volumetric efficiency of petrol engine and if you compare, first of all, we need to understand what is the volumetric efficiency. Volumetric efficiency of an engine is basically the actual volume of the air or air fuel mixture that is possible to enter the engine divided by the total the maximum capacity that is possible for that engine. The maximum capacity is also called swept volume, and the actual volume is the actual amount of air that has been fed to the engine. Okay. Now this volumetric efficiency is for petrol engine, which is also called SI engine, is somewhere between 70 to 90%, while for the diesel engine it is between 85 to 90 or 95% for naturally aspirated diesel engine. For naturally aspirated, when we say naturally aspirated, you must be thinking, what is this thing? See, one is supercharged diesel engine. For supercharged diesel engine, we don't have an application class here. In Resultant, we only have YouTube classes and plate classes. Okay, my dear. So the YouTube class is at 8 p.m. Monday to Wednesday, or sometimes maybe Monday to Thursday. My YouTube class, or mechanical YouTube class timing is 8 p.m. Monday to Sunday. Okay. On app, we don't have any classes. Supercharged diesel engine, it can have volumetric efficiency greater than 100%. Okay, so volumetric efficiency of petrol engine is comparatively lower than diesel engine. CI engine means diesel engine we are talking about. The power developed by what is the reason behind that? The reason behind this is because petrol engine eats air and petrol. Because it eats petrol along with air, so the capacity of this mixture that can be fed into the petrol engine will be less. As compared to CI engine, it takes air. And air, you all know that air only. While suction, it takes only air. But as you know, air is a compressible fluid, and it has a property that it can be compressed. And because of the compressible nature of the air, you can make the air more air can enter in the same volume as compared to the air fuel mixture. So that is why diesel engine have more volumetric efficiency than petrol engine. The power developed by a diesel engine is not increased by. The power developed by diesel engine can be increased if you have more compression ratio, if you have better atomization, excess supply of air, or supplying the air at increased pressure. See, supplying more air, supplying high compression ratio and increased pressure, they all can basically increase the power, but fine atomization of the fuel, if you have more better atomization of the fuel, it will definitely reduce, it will have reduced detonation tendency for sure, but it will not increase the power capacity. It is not that it will increase more power of the diesel engine, but it will, yes, reduce detonation. Are you getting my point? Yes, everyone. It will definitely reduce detonation tendency, but not increase the power. Power can increase by high compression ratio, because see, if you have more compression ratio, that obviously you can get more temperature, right? And more pressure. Then pressure will also be more. Okay. So compression ratio is more, pressure will be more, temperature will be more, and you can get more power, more supply of air, more lean mixture, more power. Increase pressure, supercharging. Supercharging is basically done to increase power of the diesel engine. But all these factors will increase power, not this factor. CP and CV, specific heated constant pressure and volume for diesel engine, are given 1 and 0.718. Temperature at the beginning and end of heat addition process are also given. The heat added is equal to how much? We are talking about diesel cycle here, and we all know that in diesel cycle, in case of diesel cycle, the process of heat addition is done at constant pressure, and we know that heat supplied at constant pressure is equal to what? It is equal to heat supplied at constant pressure is equal to change in enthalpy, which is equal to mCp T3 minus T2, right? This concept you have studied in thermodynamics, that heat supplied constant pressure is equal to change in enthalpy, which is equal to this. So from here you can get heat supplied constant pressure, because they are asking per unit mass, kilojoule per kg. So that is why this will be Cp T3 minus T2. Cp in this case is given as 1, T3 is highest temperature, T3 is the maximum temperature, which is definitely 1973, and temperature the beginning and end of heat addition. Heat addition is done at constant pressure, so this temperature T2 will be equal to 1723. Sorry, 1723. This will be 1973 minus 1723. Solve it, you will get answer as option A, 250. Clear? Is it clear to everyone? Operation of forcing additional air under pressure into the engine cylinder. This operation of forcing more air into the engine cylinder is called as supercharging. It is done basically for diesel engine. If you do it for petrol engine, then this will definitely produce knocking in petrol engine. It is used for diesel engine. In diesel engine, if you force more air, how you are forcing more air? This supercharger, we use a device called supercharger and turbocharger for that purpose. Supercharger is nothing but an air compressor. Now this air compressor, as you know that it has a tendency, it will provide you more increased pressure. If the pressure will be more, the density of the air will be more. If density of the air will be more, the density will be equal to mass per unit volume. So in the same volume of the engine, the density will be increased, mass will increase, more mass of air will enter, more power you will obtain. Okay, so this is called supercharging, done preferably for diesel engine. Again, we have a process called as removing the exhaust gases from the engine cylinder, which are present after combustion. Obviously, if you do combustion, you will find some gases which are exhaust gases, and that has to be removed. That is the very process that we all follow. If you eat something, you have to take out the previous material so that you can get more food in fresh food in your body, right? Same is followed for the engine also. In engine, when we do combustion, after combustion you get power, but after combustion the gases which are present are called exhaust gases, and those gases have to be expelled from the engine. They have to be removed from the engine so that you can get more, you can get fresh food for the engine. Okay, so this whole process of removing the burned gases, exhaust gases, and allowing the fresh air, fresh charge to enter the engine is called as scavenging. Okay, choose the correct answer from the following 4 options. We have basically 4 options. These 4 options, it is talking about A, B, C and D. From these 4 options you have to choose, and there are 2 statements which are given here. This is statement number 1. Statement number 1. In statement number 1, it is given higher volumetric efficiency due to more time for mixture intake in 4-stroke engine. While statement number 2, it is given, the statement number 2 is lower volumetric efficiency due to lesser time for mixture intake in the 2-stroke engine. Well, if you see individually, both the statement 1 and 2 are correct. If in context of 4-stroke engine, 2-stroke engine, the statement which are given about the volumetric efficiency and the reason for having more volumetric efficiency for 4-stroke and reason for having less volumetric efficiency for 2-stroke is correct. That means both the statement 1 and 2 are correct. As you all know that in a 2-stroke engine, all the operations have to be performed in just 2-stroke. That is, suction and compression are done together. So we have definitely less time for the fuel to enter or air fuel to enter inside the engine. It is done in single stroke. In single stroke, you tend to do 2 processes, while in 4-stroke we have a plenty of time. 4-stroke we have a plenty of time for suction. One single stroke is dedicated for suction thing. Okay, so definitely you have more time for suction. One single stroke is dedicated for suction. Here, for in single stroke you have to do not just suction but compression also. So that means you have less time for allowing the charge to enter the 2-stroke engine than as compared to 4-stroke engine. And you know that if less charge will enter the engine, the volumetric efficiency will be less. So that is why the lower volumetric efficiency for 2-stroke as compared to 4-stroke. Next question, also the last question of today's session. The question is from rope brake dynamometer. It is a possibility that in your SSC JE CBT2 or RRB JE CBT2, you can find a numerical also from dynamometer things. Like dynamometer, we all know it is used to find the brake power of the engine, but there can be a numerical also from dynamometer. And when the numerical will come, they will ask you, let's say rope brake dynamometer. In rope brake dynamometer, the formula for finding, this is the things given: dead load, spring balance reading. So we know it is used to find brake power. We use a rope which is basically wound around a pulley, and that pulley is used to lift a load, and that load is basically balanced with a spring balance, right? You must have seen a rope brake dynamometer. I don't have an image for that. You can check that in the Google also. So what is the formula for finding the brake power? Brake power formula is, see, first of all we need to understand what is brake power. Brake power is equal to what? It is equal to torque into angular velocity. Torque is equal to what? Torque is equal to force into this thing radius, and this is equal to pi, omega is equal to pi dn by 60. Okay, the force is nothing but the weight. Now here the weight that we'll be using is, one is the dead load minus the spring weight, the reading that is presented on the spring dial, into, now here we have two types of diameter. One is diameter of the rope, right, and one is the diameter of the wheel diameter. So we'll just add the two diameter, that is d plus d. Next we have pi into n by 60. So this will be the formula, weight minus spring balance reading, and the diameter will be added. So this will be the formula. Remember this formula. The diameter of the rope and pulley of wheel will be added, and the weight, that is dead load and spring balance, this will be subtracted. And next is pi into n by 60. This is how you will get the power. So if you remember this formula, you can easily get the answer. Option D is the right answer. You can check it. If you are having any doubt, you can also check it. Okay, this is the formula. And when the numerical will come, you have to use this formula only. Okay. Rest of the question will take in some other sessions. So that's all for today. I hope you enjoyed today's session. Tomorrow we are going to take the questions on power plant. Tomorrow we'll take the questions on power plant and RAC, refrigeration, air conditioning. So these two topics will be taken care of tomorrow at 8 p.m. This is the timing of YouTube session. Okay. So I'll see you tomorrow. If you have liked the session, then please do not hesitate to hit the like button, and also please share the session so that more and more students can know about our YouTube channel. They can attend the sessions, they can join the sessions, and they can get benefited from the session. Also, if anyone is new on this platform, our YouTube channel, then please do subscribe our channel and press the bell icon. Thank you so much. Have a nice day. I'll see you tomorrow at 8 p.m. Thank you everyone. Have a nice day.